From here. Thank you, and thank you everyone for coming along today. I am a secondee from Bilfinger, so I am delighted to introduce my colleague Bob Taylor, who will be delivering a joint presentation with Mark Sanders from Tomasetti. So Bob, Mark, without giving too much away, can you tell us a little bit about your talk today?
Certainly, Sarah. Thank you very much. Good afternoon, everyone. Passive fire protection, what does it mean for fire protection? In my experience, and this is where I show my naivety, and my colleague here, Mark, is going to help us. Fire protection for me has always been about fire pumps, deluge sets, fine water mist spray. That was it. That's what we know. That's who we know who owns it. We know why it's there. We know what it's designed to do, and we know its performance standard. Passive fire protection, yeah, that's not so clear, is it? Who owns that? Why is it there? And why is it not there? So that's the subject of our conversation for today. We hope you're going to enjoy, and I'll pass over to Mark. And Mark.
Okay, great, thank you. We are all looking forward to hearing about it. Your 20 minutes starts now.
As I say, good afternoon. My name is Bob Taylor. I'm Operations Manager with Bilfinger Salamis, based over at Bridge of Dawn. And I'm joined this afternoon by my colleague, Mark Sanders from MMI Thornton Tomasetti. So we've been told we have 20 minutes, and the clock is ticking, so I have to keep an eye on the clock. And as I say, we're going to talk about passive fire protection. So I've been in this industry now for 25 years, mainly operations, maintenance, asset integrity. That has been my background. Passive fire protection sits within that. What did I know about it? Not a lot compared to what I know now. My colleague Mark Sanders has been with MMI Thornton Tomasetti for a few years, 25 years in the industry. Mark is a consultant in fire protection, so a really knowledgeable person around to help us to answer some of these questions about why is it there and why is it not here and who owns it, so we can help with that. So I hope this is going to be informative, and I hope you're going to enjoy. I'm sure you will, and we've really made quite a bit of effort to use this fantastic facility here in OGTC with the slides and what have you. So we'll move on. We've called our talk today the silent insurance barrier, because basically that's what it is. It sits there as a silent barrier. PFP, passive fire protection. That's what it is. So it is silent, but it is our insurance barrier. So barriers. Everybody talks about barriers in our industry. Everybody talks about, we all know about the James Reason Swiss cheese model, 1990. It's been used by many, many different industries. It's evolved, different people's interpretations of what do we mean by the barriers. Now, I'm sure everybody here has seen the barriers, has got their own interpretation of what it is. What I've tried to do here with this slide is basically just slim it down into what we're talking about. So if we look on the far right, far left as you're looking, the hazard. The hazard there, for the purpose of our talk this afternoon, the hazard there is a hydrocarbon release. That's what we're going to base this on. Hydrocarbon release finds an ignition source. That is what we're trying to mitigate against. So the barriers here grouped. Engineering controls would be the first one. Engineering controls, the design of the installation, the pressure systems, and I would also include in that the maintenance and the operations of that. So I would put engineering controls under that first barrier. Your next barrier there, administrative controls, your processes, procedures, how up to date are these? These are what people work to, how robust are these? We then come to the behavioural controls, the human factors. What effect does that have? So clearly going from left to right, we're looking at if your engineering controls were robust, that's a solid barrier, we are protected. If that barrier starts getting mitigated, starts getting some degradation in there, you're then starting to rely on the barriers coming further down. How robust are your procedures? How well do the people know the procedures? So we're looking for this. This one here is robust, you've got a method of control. That one starts to get impaired. Now you're relying on people. Now you're relying on human people, on human factors. Everybody here, we're all the same. We are all fallible. We will all make mistakes. We will all make errors. If we have a degraded right the way through, what's the next thing we get? An incident. That's what we're talking about now. We've had an incident. What's our protection? Now we're talking about mitigation. Now we're talking about limiting the incident to something we can do. So the rest of this talk now, passive fire protection, PFP, is about this mitigation barrier. This is what we're trying to do, is to stop that escalation, to give us time. The fight or flight. Do we fight the incident or do we run away? PFP gives us that time. That's what it's there to do, to buy us time. And on that, I'm going to hand over to my colleague, Mark. Thank you.
Thanks, Bob. Good afternoon. Right here we've got the size of fires that you could possibly get. Everybody knows Piper Alpha. Everybody knows Deepwater Horizon. Bombay High North, possibly not so well known. But this one, where Bob says this was just a sequence of events dropping into place, and believe it or not, that horrific fire started with a cut finger. What happened was, the chef on a multi-purpose support vessel was chopping vegetables, chopped his 2 finger ends off. There was a monsoon onshore, helicopters were grounded, so they decided to take him to the medic on the platform by crane lift, basket or billy pew or whatever, from the capsule from the back of the heli deck. So they started going into the platform. The azimuth thrusters went, so they had to change the plan, and they reversed in under manual control. The swell got up, rammed the heli deck, the rear-mounted heli deck, into the riser, and that's what ensued. 22 people lost their lives altogether. Them 3 fires, there's 200 people died there. Well, that was just a sequence of events dropping into place. And if you look at the dates, they're a few years ago, right? Still happening. A couple of weeks ago in the North Sea, we had 2 fires in one day. Not this magnitude, but nonetheless, we had 2 fires in one day. So Bob's already spoke about active protection. What the problem is with active protection is, if you get a preceding explosion, it just takes it out, and you haven't got any protection. Passive fire protection, like Bob says, it just sits there, silently, just waits. All it uses is the heat of the fire for it to work. It's got to be available all the time, so it just sits there like an insurance barrier. Now, why do you need it? Well, steel's very, very strong, right? But if you have a look at this graph, just above 400 degrees, it starts losing strength very rapidly. It drops away. So offshore, we try and protect the steel to keep the temperatures below 400 degrees before that strength, the strength loss starts occurring. Onshore, we can relax that a little bit, because the steel's not so heavily utilised. When that Bombay High North platform collapsed, it was 7 stories high. Like, the steel was heavily utilised. Onshore, it's not so heavily utilised. You haven't got drilling derricks and multi-decks vessels and things piled up on top of each other. So you can relax that to 538 degrees C. Now, that seems a bit of an odd number, but it's exactly 1,000 degrees Fahrenheit. Here's the one here. This is the Hercules 265, happened in 2013. There wasn't any fatalities, but look at the state of that Texas deck. It's just melted. Why does that happen? This might shock a few people. There's a few figures there. That's the times to failure on unprotected steel. On a jet fire, jacket leg buckling, 15 minutes. If you have a look at that clock there, we've been speaking for 12, nearly 13 minutes. So that's how quickly it happens. Sorry, Bill. So what do? We can model. We've got some models here. We can predict where the collapses are going to happen. There's one. There's the other one here. We can predict exactly where the PFP is required in this area here. That's a flare tower collapsing. Once you've blown down, gotten rid of the inventory of gas, that can fall into the sea. That one sticks out at an angle. Lots of platforms have got vertical flare towers. So what you do is you put the PFP in certain places, and you get a preferential collapse. So you get it to collapse away from the TR or the lifeboats or whatever, so it just falls into the sea. Forgive me if I'm going a bit fast, but we've got a bit of ground to cover here. Right, so PFP, like Bob says, it's fight or flight. You either fight the fire or it gives you time to evacuate. Where do you put it? Right, we typically protect safety or environmental critical elements. There's a few there: vessels, pipe supports, ESDVs, structural steel. PFP just buys you time. Doesn't last forever, just buys you time. So, you've got your PFP. How long do you need it for? There's a bit of confusion around these usually, H&A fire ratings. People normally, everybody will have seen A60 fire ratings. What does that mean? Well, offshore it's probably the wrong fire rating anyway because it's against cellulosic fires. Cellulosic is just paper and wood, cardboard, things like that. You're not going to get that on an oil and gas platform unless it's in the accommodation or behind the galley. H ratings, that's a hydrocarbon fire. Now, what it means is, an A rating, it's 1 hour, stability and integrity. It's got to remain intact and prevent the passage of smoke and gas for 60 minutes. An H rating, doesn't matter what the number says, it's a 2 hours. It's got to maintain its stability and it's got to prevent the passage of smoke and gas for 2 hours. What the numbers mean on both, on the cellulosic and hydrocarbon, numbers means how long it takes for the back face, that's the side away from the fire, to heat up to 140 degrees. 2 hour test, but H60 means the back face has got to remain relatively cool for 60 minutes, below 140 degrees for 60 minutes. H120, it's got to stay for 2 hours. How do we work that out? We do some testing. Cellulosic and hydrocarbon for pool fires is normally done in a furnace, a bit like that. It's tested. The jet fire rating, which is a J rating, is done in a jet fire test rig. Now, the jet fire rating's different because if you had a J60, that means it's got to resist the jet fire for 60 minutes. Insulation doesn't come into it. How do you know how much steel you need? Both of those beams, those I-beams, are the same height and the same width, but obviously one's thicker than the other. So it's got a bigger cross-sectional area. So the thicker the steel, the longer it takes to heat up, so you need less PFP than what you would on some thin stuff. What happens in a fire? One type of PFP is lightweight cementitious stuff, which is basically Portland cement and a lightweight material like vermiculite mixed up. What happens is it's mixed up with water, so you've got chemically bound water. That boils off, keeps it cool for a while, and then what you've got, the remaining material, once the water's boiled off, it's got a low thermal conductivity, and that stops the heat getting through to the steel. So that's pretty common on old installations and onshore. Epoxy and tumescent, that works in a different way. It's different reactive chemicals bound up in a resin matrix, and when the fire hits it, they start reacting. You've got spumifics, you've got char hardeners, and that forms like a carbonaceous char, and the thick char stops the heat transferring through the steel. But it doesn't last forever. This material burns away all the time until it's consumed. So the PFP doesn't last forever. The screen's not long enough. There's another one there, it's epoxy subliming material. You don't see it so often now, but what happens is it's an epoxy, and when the fire hits it, it sublimes straight from a solid to a gas, and that's what keeps the surface cool, just keeps emitting gas, but it burns away as well, doesn't last forever. Right, here's the ultimate fire test. This is where the epoxies came from space technology. Came from space technology, and it was invented in the States by the Aviation Corporation of America. The Apollo 10 capsule there, that's a photograph of the bottom of the command module, and you can see that in the Science Museum in London. I think I've gone a bit too fast.
That's okay, we can open up to questions.
Becca, can I just, sorry,
Yeah.
Rebecca, just
Yeah, go for
2
it.
seconds. So I hope that's really been interesting. It's such a complex subject, and I had my learning curve still been like this, speaking to Mark in the last few years. So many different facets of this. And previously, when I started this industry, I worked offshore as a maintenance supervisor. Passive fire protection to me was something that it was there, I knew about it, and when the guys come out to put it on, take it off, do repairs. I'll be honest, hands up, I saw them as a nuisance. They had scaffolding everywhere, they had boards everywhere, they had habitats built everywhere. It stopped me getting to the stores as quick as I wanted to get there. It stopped me getting to, God forbid, the tea shack as quick as I wanted to get to. Had I known then what I know now, my attitude would have been completely different to that. I would have seen the value in why that is there. But at the time, I didn't. And I don't believe in the industry and our colleagues offshore, that message gets through either. PFP is not well respected offshore for what it's there to do and the amount of design and experience and knowledge that has gone into that. So, I think we're on time now, so just thank a couple of people if I may.
Yeah, go for it.
Thank you. So a couple of people I'd like to thank, obviously, my colleague Mark and Graham from MMI Thornton, Tomasetti, and some of their team who are here. Thanks so much for coming along. I'd also like to thank my colleagues in Bilfinger, Salamis, for helping put this together. In particular one, I thought the slides were fabulous, the depth of them and what we've got. And it's one of our guys who's a graphic designer, Robin, who just saw it and says, I want to make this pop. And I think he's done that. I think these were fabulous slides, fabulous photographs. And also as well, if I may, the staff of OGTC, Sarah, who's Bilfinger, one of my colleagues as well, so she's got two hats on. I'd just like to thank all the staff at OGTC for your kindness and generosity for us today. Thank you very much.
You're welcome. It's an interesting topic, and obviously one that had been talked about this week upstairs, and before we open up to questions, and everybody said, PFP, what is that? And why do we really care about it? And hopefully this brings it a bit more to the forefront that us as integrity people, we understand some of the challenges with applying it and maintaining it and obviously inspecting it. But for hopefully the rest of the audience, it's maybe given an insight into, yes, this can be a very, very important piece of our operations. So I'd like to open up to the floor. Any questions for these guys?
Hi, thanks for your presentation. I'm interested in the degradation or the time frame that you have between maintenance cycles and you know what it is that has to be done, barring the fact that you've maybe got an underlying fault, just on the material itself.
Well, there's a multitude of materials. I briefly touched on PFP. I didn't even scratch the surface. It's a huge, huge subject. It just depends on what the material is. We worked with the HSE and a lot of the operators a few years ago, and we developed the HSE, from the work that we did, the HSE developed the acceptance criteria for damaged fire protection. And that was mainly to do with cementitious and epoxies, but obviously we've done some work since to incorporate penetration seals, jackets, flexible jackets and what have you. It's a huge, huge subject. That was just a skim over it, really, 20 minutes. I can't really do it justice. So it depends what the material is, where it is, what it's been exposed to, and what your performance standards are. What sort of fires it's going to see.
It's a really good question, though, isn't it? Because in my experience, and I'm only speaking from mine, we set performance standards for fire pump kicking in and ability to start and deluge sets. We've got performance standards for them, and they're written into our written schemes. I don't recall ever seeing one for PFP. Maybe there are, but I don't recall having gone into that level of investigation to say, well, how do we test it?
Well,
when do we test it?
We at MMI, we've written performance standards for some operators. Some have got their own, but we've written some for some operators.
Yeah, okay.
But it depends largely on the material. What's it seeing? What's the fire threat?
So can you actually identify other parts of the world that you would recommend a more robust type of material to be used on a structure?
I've inspected PFP in North Africa, Australia, America, all around the world. It's basically the same materials. Because a fire's a fire, but it's just the environment that it's in. You're exactly right. It just depends. It's got to be specified correctly at the very beginning.
Hi, it's not a question really, it's just a comment to make that as well as global regions, it matters where it's exposed. So the conditions of exposure. So offshore, is completely different to onshore. Not onshore in a hot, dry country, you'll get for some certain types of PFP, you'll get much longer life than you will for the same PFP in a wet, cold, damp environment.
It just depends. It's got to be specified correctly in the first place, because I think what Graham says, what's good for Saudi Arabia or Dubai is no good in the Arctic.
Yeah, my question's on the inspection of PFP. So you probably know that NDT technicians and OIEs are on our assets and doing structural inspections that probably will include the condition of the PFP. Are there any sort of competency schemes or training schemes that we should be pushing our inspection providers towards?
Billy, there are two PFP inspector schemes out there. One's 8 hours on a computer, right? The other one's a 2-day course, right? You cannot teach anybody anything, and people shouldn't call themselves a PFP inspector for doing 8 hours on a computer, because PFP inspection is very tactile and touchy-feely and knowledge-based, right? However, there's an organisation called PFPnet which has been set up. I think Total are represented there, and they're busy developing an owner's inspection course for PFP. But I think it's mainly going to be geared towards new builds. But there is definitely a requirement for inspection on aged, degraded materials.
Could maybe be a project for OGTC?
Thank you, Billy. I think that's the 4th time I've heard you say that this week.
No, it's very important.
I
though.
suppose moving on from that piece as well, it's around about, but we're going into late life management, and some of these barriers are now maybe not as effective. So do we think the industry has got a good handle on managing these coatings now that they're maybe beyond their optimum performance?
There's a vast difference. Look, we work for all the operators, right, all around the world. And I've got a league table in my head which is going to stay there, right? What I think's a good operator and what I think's a bad operator, right? They remain nameless, but there's a gulf between best practice and what some people do.
I think it's really interesting, the late life piece, as we get the aging assets, change of ownership, different priorities coming in, and maybe the PFP net maybe considering that aspect of the industry, because that's really, you've got your Killanes, you've got your Mariners, Clare Ridge, brand new, and we're doing all the clever stuff with spraying on for weight control, really clever that they're doing, but there are a lot of insulations there that we all know, without 30 years old, 35 years, that are there, what condition are they in? It's a really interesting point, that, yeah.
See, you only need PFP if you have a fire, right? Now, a lot of the installations I've been to, we spoke about barriers and events dropping into place. Lots of the places have got half the events already in place, i.e. lots of gas and lots of corrosion. Right? We've had a couple of fires the last few weeks. We had a gas release a couple of years ago that would have been the same size as the ones I showed you if it had ignited. Right? With gas releases, hydrocarbon releases every month. Just a matter of time before the two meet up and we've got another incident. So
the industry's in a lot with the hydrocarbon releases. I think that the latest figures for OG UK and step change is showing that minor releases we're getting on top of, they're dropping, but the major releases are the ones that we're staying consistently on. So if we were to become comfortable, we're in the wrong place. We need to be, I can't remember the term for it, that feeling of stress. We should feel that all the time and question ourselves all the time. Have we got the right written schemes? Are our performance standards still suitable for a condition as the insulation changes, your reservoir conditions change? Everything's changing all the time. So to say it was okay 15 years ago, 20 years ago, further down the line now. So it's a good question.
I'm still sort of targeting on the integrity side of things now. One of the things, I was offshore for many, many years, like yourself, but I'd never heard of this PFP until recently. And I guess that's still the same for many of the guys, the boots on the offshore platforms and so on. And just thinking that the message that you're sending now is part of the, assurance, if you like, might be a good message for these facilities out there, for that to get across to the guys so that they're aware, because they're the ones that's going to maybe notice something, that could have degradation or whatever. And so the message that you're sending here is great, but I think there should be a wider spread of that to the facilities, the people that are going out there, the boots on the platform, so they, if they see something, they're aware of the potential.
Yeah, as I said earlier, when I was offshore, I probably walked past this, PFP with a crack on it, lumps hanging off the side. It was always like that. You get used to it, don't you? Maybe the people, so you can get the techs walking about the platform, or the deck crew, whoever, on there. We've got people that are working at rope access now. The industry's using rope access significantly more than we used to. So we've actually now got a pool of resource with the eyes at a level that we could never see before, that really could aid to that. So it's educating people around the importance of it, what good looks like, and what bad looks like and needs to get reported on. So that's a good point. And the Major Accident Hazard, the Step Change series of videos that are absolutely brilliant. I love those Step Change videos and the work packs for them. Have a look through them. I don't think there's any of them touching PFP, actually. I don't think it does. So, yeah, good point.
Hi there. I guess what I was wanting to ask was about a point that I think's been missed out a little bit, as fantastic as the presentation was, and that was the CUI element of PFP. And I know GTC are, very keen on the kind of CUI element, and from my perspective, that's a massive concern in terms of the PFP that we've currently got offshore in the North Sea, and being that a lot of it's been on there uninspected, other than visual, as the chap here's touched on before, and even then the visual inspections are not specifically PFP related by people that have maybe took the 2-day course as a maximum and call themselves experts. So I just wondered what your thoughts on were the CUI element, and if there's any kind of enhancements in the materials that we're using that are going towards kind of identification of the corrosion under the insulation, or corrosion under the fireproofing, as it were.
It does occur, called CUF, corrosion under fireproofing. I was on a platform like a couple of years ago, and they had tiles, PFP tiles, on the TR. As it happens, I told them that the fixings were starting to corrode, will allow it to become a dropped object hazard. Didn't do anything about it. Lo and behold, 18 months later, tiles started falling off. So they thought that they'd do something about it. So when they got look, they started taking the tiles off. I mean, it was quite a responsible operator, but they started taking the tiles off. When they started taking them off, there was holes in the TR. So it wasn't gas tight. So they had to address that, as well as replacing the PFP. They had to address the holes in the TR. So it does happen. I've seen it on pipes.
Yeah, oh, definitely. It's just really like what we can do as a supplier, I guess, and as a applicator, if you like, through Bilfinger, and from the inspection side of things, to really kind of try and bring this more to prominence, because I think the CUI or CUF piece is completely out of sight, to be honest, because like you say, it's just something that you walk past. But I've been offshore on platforms doing hammer tests on PFP, and the whole lot comes down. An arrow's raised and it's in for repair in 24 months. I mean, it's just absolute madness. So, just how can we? I don't know if this is the forum for it, but what can we do to bring that, tie it together with the CUI issue that we're currently experiencing as suppliers, as applicators, as inspection bodies, whatever it is.
I probably shouldn't say this, but CUI, when it's affecting production, holy pipes and things, that's a big problem, right? Yeah. Under the PFP, like I say, you only need the PFP if you have a fire, right? And there's a lot of complacency there. Right? showed you pictures of some massive fires, right? Still happening. I don't know what the answer is. It's got to be raised.
I know there's not an answer, but it just
I think the awareness of the CUI and process pipework has increased dramatically, you know, as industries. Hydrocarbon releases are just, you know, so that was one area. Hydrocarbon release working group looked at all that. Corrosion under insulation, small bore tubing, so they looked at all the different areas right across Norwegian sector and UK sector, and that was recognised. So certainly OGTC are doing a lot with coming up with newer techniques rather than ripping it off to sea, and that will come with new technology. Your point about the waiting 2 years to get it fixed, without knowing the exact, I would suggest that maybe comes into two things. One is a lack of understanding why it's there again, and saying, well, that's acceptable, they sit like for that for 2 years. So let's not criticise the people who made that decision, because they probably made it based on what they thought, what they knew about, and that's the reason we're human beings. But there are a lot of products out there that Mark was telling me about there, that you can do a repair on it. It doesn't mean, like I've seen in the past, what I was alluding to earlier, whole place getting scaffolded out, tarpaulins, you know, habitats. Doesn't need that anymore. Rope access, guys getting in it and doing localised repairs that return it back to an acceptable standard. So it's getting that knowledge. One is the knowledge about why, and secondly about what's actually out there now, because we've moved on quite a bit. But a good point.
It's not just that, Bob. PFP, by and large, once it starts degrading, once it starts, it doesn't get any better. It just gets worse rapidly, because it's either cracked or split or disbonded. You're getting water in, and it's just magnifying the problems. So once you've got damage, you need to address it straight away. It's no good saying, oh, that'll be fine for 2 years, you know, which is what happens.
Just one quick comment, really. Thanks for the presentation. For everyone's information, the Energy Institute does have a working group underway looking at an in-service management of passive fire protection, which brings in some of the stuff that MII did with the Joint Industry Project. But the other quick thing for Bilfinger as well is, as an inspection company, what are you doing proactively to get your inspectors competent and qualified to do this?
I'm going to pass on that because I don't know, but I'll ask the question. You know, we'll ask you that, because the point Mark was making about a 2-day course, I wasn't even aware of that. So I'll ask. I'd also like as well, though, we've got the rope access guys, and this isn't a sales pitch for Bilfinger, but we've got the biggest number of rope access trained people on our books in the UK. Actually, can we do something with these guys? They don't have to be inspectors to know what good looks like. So I always used to say when we're offshore, you've got an OIE who's got one pair of eyes, but we've got 120 people there. So if you tell them what good looks like and what not, when they're walking about and they're looking at gratings, looking at PFP, they're looking at whatever, you've increased dramatically your visibility, if you like, around that. But thanks for it anyway. I will ask that question next week, and I'll get it. Okay, thank you.
You mentioned the I document. Graham wrote that document.
Hi. I would like to ask if there is any kind of legislation similar to what you do with aircrafts and the black box, that we have eyes everywhere and we can track what happened in the case that this happens, because obviously in order to learn we need to monitor.
Like a passive monitoring sort of system, you mean?
Well, basically like cameras or something that are tracking what is going on every time, and they keep the information safe, because it's basically when you've got an incident or an accident, in this case, something big, the information will likely going to be destroyed. But if you keep that somehow in a safety box, we can then track and know what happened.
Imagine that the fire protection materials, like I said before, it encompasses a whole spectrum of different materials, and I'm sure there's something that they can use to protect cameras and information out. But as regards PFP, you cannot use artificial. We've looked at it. We've got a department that deals with artificial intelligence. They're looking at concrete things in the States and bridges. There's our head offices in Wall Street in New York. We do a lot of stuff with artificial intelligence, right? But with PFP, it's very tactile. It's touchy-feely. You've got to knock it, tap it. You've got to feel if it's soft, if it's wet, if it's crumbly. You cannot tell that from a photograph. I mean, I've had loads of times I've had guys send me photographs and says, "What, is this all right, Mark?" It's 2D, it's a photograph. I cannot tell if it's disbonded, what the reinforcement's like, if it's wet, if it's dry, if it's...
Yeah, but my point was that if you address a few, well, you identify a couple of places where it's more likely the fire to come in the first place, you're talking about a mitigating way of, just trying to avoid the catastrophe if you want. But to me, the point was more if there is a legal binding to put things in place to monitor in order to learn how to avoid, in the first place,
Funnily enough, there isn't a great lot of legislation about PFP, to be honest. I mean, you've got the safety case regs and things that came out of Piper Alpha, the Lord Cullen report. But really, the only one where there's any legislation that says you must is the Pipeline Safety Regs 1996. And that's about the ESDV valves. Right? That's the only legislation what specifically says about PFP. It's got to remain intact and be able to fulfill its function after an explosion. I
think though, on the point about cameras and positioning cameras, not just for PFP, but for monitoring the installation. And I know, Billy, if you look at the newer installations, Culzean, Mariner, Clare Ridge, the digitalisation, they are set up for the new technologies coming through. Much easier than if you go to like Ock or Fulmer or something, much more difficult to put them in there. Is there any legislation? I wouldn't think so, if I'm honest. However, if you have an incident and prosecuting the regulator, whoever it was, into investigation, if you knew about something and you didn't take reasonable steps to mitigate, do that elimination and monitor, and that was one of them that somebody asked, well, should you have? You'd have to make the case. But I don't think there's legislation that says it, really. Unless anybody's got anything else on it. But I wouldn't have thought there's anything there.
Well, there's only legislation, there's the Pipeline Safety Regs.
Yeah.
There's plenty of guidelines out there, and you'd have a bit of explaining to do if you had a big fire, and you've got guidelines from the Oil and Gas UK and things. So you're a full member of Oil and Gas UK. They recommended that you do this. Why haven't you done it?
Yeah.
You'd have some explaining to do to the bloke with the curly wig.
So what is best practice? What do you do? I know our older platforms, I was in Dunland for years, and we had cameras in the legs then. Comet Alpha had cameras in the legs for monitoring for leaks rather than putting people inside the legs. So it has been done. In the newer platforms, it's easier to do. But it's just, where do you put them?
But the thing is that when you showed your presentation, there were pictures which can't track really what happened at the very beginning of the situation. And I think that's crucial in order to learn, never mind liabilities or something like that. I was not, just trying to look at that. That could be interesting.
Pictures paint 1,000 words if you can see exactly what happened. I know what you mean.
Yeah, but the video is even more than 1,000 words. It's a million words.
There's any legislation where it says you've got to film. I mean, there's plenty of cameras around platforms, but I don't think there's any specific legislation that says you must record this and keep it for 5 years.
But Billy, you've got a microphone. Has Culzean got cameras dotted around there?
I'm quite sure it does. I don't know for sure.
Yeah.
But anyway, I have an additional question. So obviously PFP impacts upon the inspectability of pipework for CUI, pressure vessels for non-intrusive inspection, ESDVs. So there are removable PFP systems on the market.
Yes.
A couple of questions. Have you seen an increase in the use of removable PFP? And where they are used, removable panels, etc., are they as effective as a traditional sort of PFP approach?
Billy, I've seen a lot of flexible jackets, right? And they're very, very good. Lots of places where you can't use anything else. But what happens is they get took off and they don't get put back on. The first time that somebody's got to go and unlace something to get into something or unbolt something to look at it, just leave it. I've got to be back there next week. There's a lot of complacency, and that's the problem.
We see that a lot with the process pipe, don't we? Process insulation comes off not just for PFP but on the pipers. it comes off, sparkies go in, heat tracing, and there it remains. Yeah. So it's knowledge, isn't it? It's about why it's there. Absolutely. Couldn't possibly comment.
One last question. Okay. I was interested in that hammer test that...
Wheel tappers and shunter social club, is that what you were thinking
well,
about?
the volume of the material that actually came down on a tap test. And it just, being involved in asset integrity and strategy management and so on, myself, what knowledge are you able to retain from reports of, say, this incident, whereby you could say, well, look, we've had this on site for X amount of years, exposed to this is what's occurred, there's a likelihood this could be elsewhere in this arena or on another facility in this environment, and how is that knowledge shared? Is there a bank of analysis that you could actually, put forward strategies for improved? There's not.
There's not, no. Well, recently there was an operator, a company went out and inspected something and gave it a clean bill of health. Fortnight later, it all fell off because the guys didn't know what they were looking at. They shouldn't have been inspecting it in the first place. I mean, you're on about the tap test, right? Tap test is brilliant. I use it all the time. But you've got to know what you're looking at. You've got to know, if the reinforcement's okay, a little bit of disbondment doesn't matter. You know, we learned that from the GIP that we did and the acceptance criteria. So you've got to look at things together. You know, is it cracked? Is it disbonded? If the pins rotting away, is the water getting in behind? You've got to take everything into what's good in one place might not be good in another.
Yeah, if looking at the analysis side of things, then that would give you some kind of strategy or a beginning as to where to start to improve your then cycles of inspection or what to look for.
That's right. That's right. Like you said, if you've inspected something every year for 10 years and found nothing, you can bet your boots 11th and 12th year there's not going to be nothing. Whereby if you can see things deteriorating, you need to inspect it more regularly.
Yeah, that's right.
It's common sense.
It needs to be shared. What I'm getting at is the information that you have where there has been issues, that needs to be analysed and shared so that there's...
Well, what's happening is, like I said, there's an organisation being set up called PFP Net, and a lot of the operators are members, along with manufacturers and fabric maintenance companies like Bilfinger, Stork and what have you. Total are a member, and that's where the information's getting shared. I mean, HSE, PSA, the Norwegian, like HSE, there's a everybody that's involved with PFP, anything to do with PFP should be a member. And there's all sorts of information coming out about high heat flux testing, three-sided materials onshore.
The problem is it's so much to do.
And on that note, we do have a hard stop because this room is booked after this, but we'd like to say thank you for coming along today. As we have sort of discovered, this is a big talking point. When people think about PFP, they don't always see the value in it and some of the complacency. So, yes, good conversation. I'd like to thank our speakers today, very insightful, and also the audience for a very good, engaging conversation. Some questions that we maybe do need to think about in more detail. We do these sessions every week. For those that are not too familiar, I think the next one coming up next week is the Carbon Revolution, so somebody from the National Competence Centre. So every Friday we do 20-minute lunch, 20-minute talk and 20-minute conversation. So please come along to any that you are interested in. So on that note, thank you once again with our speakers and our audience.